Hello guys, namaste. Welcome to today's class on network theory. I'm going to start a lecture series from today. Our first lecture series will be on network theory. Okay, network theory is a foundational topic in electrical and electronics engineering. So network theory as such, if we check in internet, we can see it has a vast variety of topics based on networks. So here in engineering, especially in electrical and electronics engineering, network theory deals with the behavior of electrical circuits, the analysis of electrical circuits, and how we can define, design an efficient system for real world application. Okay, so we study about the analysis, the behavior, and design aspects of electrical circuits in this subject. Okay, so we can define it as a study about electrical circuits and the behavior of interconnected components. Okay, so we study electrical circuit by examining the interconnected components. What are the interconnected components in an electrical circuit? These are the key terminologies in a network theory. They are one is node, one is branch, then there is loop, and there is mesh. Okay, so nodes, branches, loops, and mesh. They are the key components or key terminologies in a network theory. So let us see what are nodes, what are branches, what are loops, what are mesh in network theory associated with engineering. Okay, these are the terms in any network. Okay, nodes, branches, loops are in any networks. Okay, be it a psychological network or be it a neurological network or biological network. So there are many types of networks. So in engineering networks also we have these common points. So how it is associated with electrical circuits, that is what we are going to check. Okay, so in electrical circuits, nodes are points where two or more components connect. Okay, so what are the components in electrical networks? We have active components and passive components, right? Active and passive components. What are active components? Are sources that provides energy. Okay, that activates a circuit. So active components in a circuit are sources. Okay, there are different types of sources, voltage source and current source. And what are the passive components? They are just passively present in the circuit. Okay, so they doesn't act as a voltage source. So examples are resistors, capacitors, and inductors. So they are loads. We can say passive components as loads and active components as sources. Okay, so nodes are points where two or more components connect together. So consider this circuit. We have voltage sources and resistors. In this whole circuit, we have two voltage sources and one, two, three, four resistors. So here one voltage source and a resistor are connected in this point A. So A is a node. These two resistors are connected to B. So B is a node. So now two resistors and one voltage source is connected to the point C. So this point C is called as a node, and is a point where a voltage source, the negative of the voltage source and the resistor is connected. And E is another node where two resistors and a node is a point where two or more components are interconnected. So we can say comma B, comma C, comma D, comma E are the nodes of the network. Okay. So nodes in the network are A, B, C, D, and E. There are five nodes in this network. Okay. Then what is it? The next is branches. Connection between two nodes with a single circuit element is called a branch. So here between two nodes A and B, there is a single circuit element, that is resistor. So that is a branch. between B and C there is a single what resistor. Okay, that is a branch. So this is a branch, and we have this voltage source in between C and D. So this is a branch. This is a branch. And the next term is a loop and a mesh. So any closed path is called a loop. Okay, closed path in a network is called a loop. So this is a B C E A is a closed path. A B C, okay, is a closed path. Similarly, E C D E is a closed path. And what is a mesh? Okay, there is loop and then there is mesh. What is a mesh? Mesh is the smallest closed path or the shortest closed path in a loop. Okay, so we can see this is one mesh. Okay, so this is the shortest or the smallest closed path in a network. Okay, the smallest or the shortest closed path in a network is called a mesh. All meshes are loops, but all loops are not meshes. So that is one thing which we have to remember. We can call a mesh a loop, but we can't call every loop as a mesh. So the smallest one without any inner loop are called mesh. Okay, so this outer one is can only be called as a loop, but the inner ones can be called as mesh also. Okay, so I hope you are clear with what is node, what is branch, what is mesh, and what is loop. Okay, so here in this circuit we have six branches which composed of two voltage sources and four resistors, and the circuit also contains five nodes marked in green: A, B, C, D and E, and it contains three loops. The first loop is A, B, C, E, then E, C, D, E, then A, B. Loop 1 and loop 2 can be called as mesh 1 and mesh 2 because it is the smallest one. Okay, so next one is, what is the difference between a network and a circuit and network? So in electrical engineering, sometimes this subject is called circuit analysis, sometimes it is called network analysis and network synthesis. So what is the difference between network and a circuit? So we can see that circuit is an electrical pathway consisting of active component and passive components, that is sources and loads. And a network is more a general term, okay, may not necessarily function as a circuit. For example, already told network theory is more of a generic term. It can be for any system. It may not be necessary for an electrical system. So electrical network means a interconnection of elements which may or may not have current flow. But circuit is always a closed path for current flow. Okay, there will be a closed path for a circuit. Okay, and there will be current flow in this closed path. There will be a closed path and there will be a current flow. But network is interconnection of elements which may or may not have a current flow. Okay, for example, circuit can be thought as a plumbing system with a pump that creates a closed loop for the water to flow. And network can be imagined as interconnected pipes and reservoirs, but water doesn't necessarily flow in all parts of the network. Okay, it can be considered as interconnected pipes and reservoirs, but there is no guarantee that water flow in all parts of the network. There will be a current flow. Means what? There will be at least one independent source. Okay, along with the closed path, there should be a return path for the current to flow. Okay, along with the closed path there should be a return path. If any of the condition fail, if any of this condition fail, then we can call that circuit as a network. Okay, for a circuit, it will be a closed path and there should be one independent source for the current to flow and there should be a return. Okay, if any of these conditions fails, then we can say it is called a network. Okay, and what are the variables in a circuit? So we know we have voltage, current, power and resistance. Okay, all these things we already studied in the 12th, I guess. So voltage is the electrical potential difference between two points. Okay, and it is given in volts, and current is the flow of electric charge through a conductor, that is given in ampere. Okay, by Ohm's law, what is resistance? Opposition to the flow of current. Okay, if there is some opposition to the flow of current, then that opposition is called as resistance, or resistance that is given in ohms. And power, the energy used or generated in a circuit, is called power, and usually it is given in watts. So these are terms which we will deal with our later classes. So these are the basic things which you know. Now, next we have the sources. Okay, sources can be classified as two types. Okay, sources can be classified as two types, that is independent sources and dependent sources. Okay, independent sources are given from a, we can say it as a given from a battery, that is a voltage source. Okay, a current source, that is plus minus. Okay, or we can say it as an ampere. So these are independent sources. Okay, current will be shown as a arrow mark, the direction of current, which direction it is flowing. So it can be necessarily from a battery. If that is an independent source, it is not dependent on anything else. And dependent sources are of four types. They are voltage controlled voltage source, current controlled voltage source, voltage controlled current source, current controlled current source. Okay, and is usually denoted in a diamond box. Okay, if it is a voltage controlled voltage source, we will be given it as like a constant alpha into Vs. Okay, where Vs is some other voltage. If it is a current controlled voltage source, it will be given as, sorry, if it is a current controlled voltage source, it will be given as plus minus. So it is a voltage source and it will be Ig. Okay, where the value of the voltage is denoted by some other current. Okay, is controlled by some other current flowing in a circuit. And voltage control current source, it is actually a current source, but it is controlled by some other voltages. Okay, so it will be a current source. So it will be given by beta Vs, let it be. And current controlled current source will be shown in a diamond box, and it will be a, but it is controlled by another current source. Let it be gamma into I1. Okay, so 1 into gamma will be the current value flowing through the, so they are dependent sources. They will be dependent on either a voltage or a current in some other part of the circuit. Okay. So the circuit will be in such a way that it will be in some other part of the network and it will be controlling the current or the voltage. So they are dependent sources and independent sources. In this subject, we study the analysis using both dependent and independent sources. So that is why I'm introducing all these things. Okay, so when we do problems, we can understand much about this. Ideal and practical sources. So independent sources can be divided into ideal sources and practical sources. Ideal sources are theoretical sources and practical sources are practically which in real life what is available. Okay, so ideally a voltage source of 12 volt will give us 12 volt as output, whatever be the current. Okay, as current increases we get 12 volt. Okay, if we see the graph we will get 12 volt DC. Okay. So whatever be the current we will get, as current increases, we will get a practical of 12 volt as the output. Okay, this is a theoretical one. And ideal current source, if we give a 3 ampere current, as the voltage increases, we will get 3 ampere constant current. Okay, so this will be the ideal 3 ampere DC voltage source and DC current source. Okay, but practically, is it possible? No, it is not possible. Practically, for a voltage source, there will be a series resistance. Okay, so practically, there will be a whose value is very less than 50 ohm. Okay, there will be a series resistance whose resistance value will be less than 50 ohm. Okay, as a result, what happens is that our voltage source will not be a constant one, but there will be a decrease in value. Okay, so 12 volt DC will be having a load resistance included in its value. So we don't get exactly 12 volt as current increases because there is a resistance, and as a result the value we get in the output load will be different. Okay. Similarly, a current source will be having a parallel resistance RP added practically. Okay, and hence we don't get a constant 3 ampere, but we will get a decreased value. So as voltage increases, the current will not be constant. There will be a parallel resistance added to the current source. Okay, as a result, as voltage increases, the current will be different. So sources in the circuit, we can say we have ideal sources, that is the ideal voltage source and current source. We already explained all these things. Maintains constant voltage regardless of current, and ideal current source provides constant current regardless of voltage. Okay, and the practical sources have an internal resistance or impedance. Okay, so this is the graph, that is we have ideally we will be having a voltage source, and when we connect it to the load, there will not be having any resistance. As a result, we get a constant and a equal to the source voltage. But practically there will be having a series resistance in series with the voltage source. As a result, there will be a variation in the voltage source. Okay, so the graph is shown here. Similarly, for the current source, ideally the parallel resistance is assumed to be infinity, and hence we get whatever be the current we will get as the output. That is, if it is 1 ampere current, then we will get a constant 1 ampere current. But practically there is a parallel resistance. As a result, we will get reduction in the current value compared to the theoretical value. Okay, independent and dependent sources, we have already seen independent and dependent sources. Independent sources operate independently, and will be shown in circular boxes, and dependent source depends on another variable in the circuit, that is another voltage or current, and its four divisions, and it is denoted in diamond boxes. And we have some simple example with circuit with independent source. Okay, this is a battery driven circuit. So this is a dependent source, and here we have an op-amp configuration with feedback. It is an example of dependent source where the input current is regulated by the output of the circuit. So a BJT or an op-amp can be considered as a voltage control device and a current control device. So when we analyze the internal circuitry of an op-amp or a BJT, we will definitely come across the dependent sources. Okay, so next we have applications of network theory. The real world application is analyzing and distributing electrical power efficiently. Then in electronics, designing circuits for signal processing and amplification. And in communication networks, we have optimizing data transfer in wired and wireless networks. That's which we conclude our first day class on network theory. In today's class, we have seen An introduction to network theory. We said network theory focused on mainly analyzing and designing circuits. We understood what is the different sources in a circuit, that is independent source and dependent source, and what are the key components in a network. Then understood the circuit variables. Then we also explained about the ideal and practical sources. I hope you all like the video. The next video, please subscribe the channel so that you get the notification when I upload the next video. Thank you for your patience. Give your feedback. See you in the next video. Bye.